So far we discussed about array, linked list, and stack data structure. So today we'll be discussing about queue. So queue is again a logical data structure. So we can implement queue using either array or linked list physical data structures. Um, so the first thing, yeah. So okay, so this advantage I forgot to change. Yeah, just delete this. Yeah. So queue is a logical data structure, as I mentioned, and it's based on the first in, first out principle. In other words, FIFO, right? So queues are quite common for general public nowadays. You can see queues of people for petrol, diesel, gas, essential items, rice. So what you see here in this picture is a queue of people queuing up for either petrol or diesel, right? In front of a IOC petrol station. So queue is quite common, right? So the principle behind queue is that so you join the queue at the end, right? So this is a queue, right? So you join the queue at the end, and you will have to wait all the way until you go to the front of the queue to be served, right? So you join, even though you join first, so like you join first and you are the last one to be out, right? So you first in, and so you'll have to wait all the way until you come to the front of the queue to be served. So it's first in, first out. Whereas in stack, when you join, you still join to the end of the queue or the end of the array. And in stack, however, you are the first to go, right? So I'm sorry, you are the last. So it was last in, first out, right? So you are last to in. So you will be uh, entering the queue last, and you will be first out. So you don't have to wait until any time. So you'll be the first one to out, right? So whereas in this queue, you'll have to wait all the way until you go to the front of the queue to be served. So hope it is clear. So note the difference between stack and queue. So right, so queue is FIFO or first in, first out, right? Yeah, I mentioned queue can be implemented using an array or a linked list. So we'll first discuss how to implement a queue using array, right? So in queue, there are two pointers, whereas in stack, if you remember, we went with stack was implemented using just one pointer, which was, what was the pointer used for stack? Can someone tell me? Anyone? Oh, that's a basic question, right? So we only use one pointer, right? What was the main pointer used in stack? Can someone tell me? Kavind, 3633. What was the pointer, main pointer used in stack?
Top.
Yeah, good. Yeah, so we only had to use top in stack, whereas now in queue we need to use two pointers. One is front, the other one is rear. So let me explain how both works. So um, let's take a, let's say we have a queue like this implemented using array, right? So we have 1, 2, 3, 4, 5, 6, 7. There are 7 elements, and the front, what it does is it points to the front of the queue, right? So we don't have the mouse pad, so it points to the front of the queue, whereas rear, right? rear. Now say suppose we have a couple of elements over here. Let's say 3 elements, and rear, it points to the end of the queue, as the name suggests, as I mean, as it implies. So rear points to the end of the queue, front points to the front of the queue, right? Now note that rear points to similar as in stack, it points to an empty position, right? It doesn't point to over here. I mean, you can always implement it pointing over to here, to the last node, last element, which is with a value. Now, however, in our example, in the way we implement, we'll go with this implementation where rear points to an empty element, right? There is no value, right? Please take note of that. Yeah, so what happens before going to the implementation? Let me first explain how it works. So now I mentioned in queue, insertion happens at the end, right? From the backend, and there's one more variable which you need to remember, which is capacity, right? So we have to define a capacity. So the capacity, so it, as the name suggests, it says how many elements you can store in a queue, right? So the operation happens like this. So say suppose now you have this value, right? So you have this value, you need to insert to the queue. So insertion happens at the end, right? So you'll be inserting it to the end over to here, right? So the rear, once you insert this value over to here, the rear goes to the next one, right? So it goes to the next one. So it will be filled. Similarly, once you enter the values, so this stack, so this queue get filled. And once you have, once you enter a value over to this element, now your rear, which was earlier pointing to over here, it will increment by 1 and it will go over here, right? Now, when it goes over to here, what we need to do is, because this is of a fixed size, we're using array, right? So we have to move it all the way to the front if there is no elements over here. Now, in the same time, let me explain how the deletion operation, or how you read from the queue. So now, in order to read, or that operation is actually called dequeue, right? The insertion operation is called enqueue, right? And the other operation, reading value from the queue, it's called dequeue. So in that, so what we do is, so we read from the front, right? So we read from the front. So once you read this value, once you take out this value, your front variable pointer goes to this over here, right? Now this becomes an empty one, right? So you read from here, your front goes to over here. So once you read it from here, so your front goes to over here. So that's how it works, right? So there can be, so once the front comes to over here, and when you take the value out of from here, your front again needs to go to over here if it is not full. So that's how it works, right? Any questions? That's how we implement a queue using an array. So basically, your rear, once you insert, it shifts from over here to over here like this. It shifts, right? And once it comes over here, and if there is empty space over here, it goes from here to here, right? Similarly, front also shift one by one once you read the values. And once it comes here, once you read this value, it goes from over here to over here. Hope it is clear, right? So this is a situation, it's a typical situation like this. So as you can see here, the values, the front is over here, the values start from here. This is the first element, second element, third element, fourth element, like this. And this is the fifth element, sixth element, right? So that's a implementation, one instance of a queue. Any questions? Please let me know if this explanation is not quite clear for you. So let's go to the implementation of queue. Let me just go to the Visual Studio and do it over there. Yeah. So yeah, let me do it from the beginning. Yeah. So what we are trying to do over here is we are trying to create a queue using array data structure, right? So I have named the class as queue array. First thing we need to do, right? So let me take my quotes out. So let's define the member variables. We need a couple of variables. So one is front, the another one is rear. So these are the two indicators pointing to the front of the array and the front of the queue and the back of the queue. And we need, let's define a size variable. So this is basically, this indicates the current size of the queue, right? And we need the capacity variable. So this indicates the maximum size of the queue, right? Yep. And then let's have the pointer called data, which we're going to use to create the array, right? Okay. So let's define some public methods. First, the first thing we need to do, create the constructor, right? So let's pass the capacity. And so now the capacity will be equal to whatever the value passed, right? So when we create the queue, we need to define the capacity of the queue. And initially the size is 0, right? There's no elements. Front is also 0. Rear is also 0. And let's create data. Data will be like this. What should we write here? Someone tell me. At least type it in the chat. Anybody? Yeah. Got one answer. Capacity, right? So here, capacity cap both are correct. So however, we'll just go with the variable over here. I mean, cap is the one that we pass, right? So anyway, we assign cap to capacity. So let's just go with capacity. Okay. Now we have the constructor ready. Let's write the first function, right? So even here, yeah. So this is basically it, right? So this is the definition of the queue class. These are the private members, and this is the constructor. So let's go to the first function, which is enqueue. Enqueue is, I mentioned, enqueue is basically is another name for insertion operation, right? So with enqueue, so this is the insertion operation. We insert a value to the end of the queue, right? So insertion happens towards the end of the queue, right? We need to pass the value, right? Yeah. So can someone tell me first thing we need to do? I believe you should know this by now. We have done this a couple of times. So before inserting uh, anything, first thing there is something we need to do, right? What is it? Yeah, correct. So I received the answer in the chat. So the first thing we need to do, we need to check whether our cube is full or not, right? So if it is full, we can't insert anything, right? So how do we check whether our cube is full or not? Can 3673 Mauli, right? That's your name, right? Sorry if I pronounce it wrong. Can you answer? Can you tell me how do we check whether our cube is full or not using these variables, whatever we have defined over here? Mauli, 3673, Mauli S, right? Can you tell me? Come on, I have allowed you to even go with without the.
No, sir.
Yeah, can you tell me how do we check whether our queue is full or not
Uh,
using whatever the variable?
the capacity is equal to 0. No?
No, right? So capacity is the maximum size that the queue can be, right? For example, the capacity of the queue can be of size 5, right? Uh, so So if we just check whether capacity is equal to 0, then that should be wrong. I guess your answer came in the assuming that this capacity is actually the remaining capacity, right? So if this is the remaining capacity, then your answer is correct, which is we can just check whether capacity is equal to 0. That means if it is the remaining capacity, it's not actually this capacity is the absolute maximum of the maximum size of the queue, right? That the queue can be. So it doesn't change, it's a constant, right? So if it was the remaining capacity, your answer is right. So can anyone else tell me the answer? The correct answer? Dharmaratna 3568. I received a couple of answers in the chat, but they are not quite correct. Yeah, I received one correct answer. However, I would like to hear from someone. Dharmaratna 3568.
No idea, sir.
Sorry?
No idea, sir.
Okay. Should be fairly straightforward, right? So we have a variable called size, right? Which indicates the current size of the queue, right? So if the current size of the queue is exactly equal to capacity, that means the queue is full, right? Correct? Yeah. So yeah, I have received a couple of answers in the chat that which are correct. So this is like the easiest implementation to see whether the queue is full. So if the size is exactly equal to capacity, that means our queue is full, and we will just output something. Let's say queue is full. All right. Clear? This is clear. Um, Now, there is another way to do this, but I'm not going to say it. Please figure it out by yourself because that might be useful for you in future, right? Just figure it by yourself. There's another way to check the capacity without using the size variable. So it doesn't involve the size variable. It involves other variables. So try to figure out another way to check how to how check, another way to check whether the queue is full or not. Okay. So I'm just giving you pointers that might be useful in for you in future. Okay. Um, yeah. So if you listen to and take note of this all these hint or the points that I'm giving, probably this module will be quite easy for you, uh, especially in the end. Okay, so else that means the queue is not full. We can insert a value. Now we'll insert the value towards the end, right? Property of the main property of queue is the insertion happen from the end, right? So you'll join the queue from the end, right? So even when you queue for the food in the canteen, so you join the queue at the end, right? Um, so how do we do that? So our array is data, right? So we have a pointer now, right? Rear, which write it down. This indicates the end of the queue, right? So we can use rear. So and basically assign the value to over there. So if I annotate and explain this again, I'm trying to explain in different ways so that you'll understand. So we have a array like this. Probably, so let's say we have a couple of items filled. So our array, now our array is over here, right? So please excuse my handwriting. So our array is over here. So it's pointing to this element over here, which where there is no value. So now we have this value, well, right? So we need to insert it. So we need to insert it over here. So how do we do that? We simply use data. So we'll access this for this element by the index, right? So here array is index pointing to this over here. So data within square bracket real will be equal to val, right? So clear, right? So we'll be adding this value over here. Hope that is clear. And now once it is done, there is one more important thing. This is like the most important line in queue. Now the next thing we need to do is we need to increment the rear pointer, right? So the rear, basically this is the index, so we need to shift it from over here to over here, right? We can simply do that by increment its value. So now in this case rear is 0 1 2 3, rear is 3, and once we increment it will go to 4, right? Rear will be 4, right? Now yeah, and we do that, and then we need to increase the size as well, right? So our size will also be increased by 1. However, there is some issue with that. What's that? Can someone tell me what's the issue with what's missing over here? Anybody? At least type it in the chat. What's the issue? What are we missing? Lakshan 3649. Can you tell me?
The front element.
What? Sorry. So the issue is now when we increment, so it goes to here. Now, say suppose we were in a situation. Let me draw it again. Say suppose our queue look like this, and once we inserted that value, right, we inserted it over to here. So this also got filled. Now our front is somewhere over here, right? So this is front, and our rear was over here. Now we incremented it by 1, so it went over to here. However, I mentioned, right? So now our rear, if it goes from over to here, we need to shift it all the way to the front. Clear? So simply what we need to do is, so it's 0 1 2 3 4 5 6, right? This is a queue of size 7. Whereas, so if rear is equal to capacity minus 1, right? So like this last element is capacity minus 1, right? So the capacity of this queue is 7, whereas the index is 7 minus 1, which is 6, right? So if our rear was over here, right? Rear was over here, clear? When we increment it, the rear will be equal to capacity, right? So basically, if our rear is exactly equal to capacity, right? So we need to shift it from over here to all the way to the front. So we need to make rear equal, we need to make rear equal 0, right? So we need to shift it all the way to the front. This might be confusing for some of you. So hope once we do some coding, it will be clear for you. Please let me know if if you can't understand. I'll explain again. So we need to do this operation, right? So somehow, if once rear goes from over here to over here, we need to shift it all the way to the front, right? Because this is kind of a circular thing, right? So our queue the implementation of queue is kind of circular, right? Using array. So how do we do that? So we can simply do this. We can use a if condition and move it to the front. There is a special mathematical operator that can do the same thing. Can someone tell me what it is? The answers I have received in the chat, like regarding this thing, like this over here is correct. So can someone tell me how to do this with one single line using a mathematical operation? Yeah, I received the correct answer in the chat. So there's an operator called modulus, which is indicated by this percentage mark. Modulus is basically if I give you example, if you take the modulus out of like 4 out of 3, what this means is you basically divide 4 by 3, and whatever the remainder is the answer. So we take the remainder. In this case is 1, right? When you divide 4 by 3, the remainder is 1, right? So that's the modulus operation. So it basically divide whatever over here by this value and it outputs the remainder, right? So in our example, what we need to do is, once we increment the rear, right? When we increment rear by 1, right? We need to take the modulus and by capacity. There's no enough space, so please take your own notes, right? So similarly, we have to implement it. So how do we implement? Rear plus 1, take the modulus out of that. So we need to divide by capacity, and whatever the remainder will be equal to rear. So in simple words, what happens is, if I give you an example, so let's say our capacity is 5, right? Let's say our capacity is 5. Now our rear, when it goes to the last element, it will be 4, right? So capacity of 5 means 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now when rear is over here, it's 0, 1, 2, 3, 4, right? So rear will be equal to 4, right? Now when we increment rear by 1, right? So it will be 5, right? So when it is 5, once we take when we divide it by capacity and take the remainder, it will be 0, right? So once it goes once we increment it by 1, it will be 5, right? So 5 modulus out of 5, capacity is 5, right? Our capacity over here is 5. The remainder is 0, right? So then rear will be equal to 0. That means rear will go to over here. Is that correct? Is that clear? Why, there's a question, why do we need to shift the rear to the first element again? Yeah, that's the reason is, now our queue, why we do that is, right? I told you, right? It's like a circular implementation, right? So our queue is something like this, right? I mean, when it works, I mean, with the time we add element to the end and we remove element from the front as well, right? So with the time, some of the element will over here will be empty, right? So we have some spaces over here. So we need to now, let's say our queue is something like this at this moment, so we have some space over here, right? So we need, now that means our queue is not full. So whatever the element we need to insert, we can insert over to here, right? So this might be a little bit confusing because we are using array to implement this. Now the thing with array, if you remember, array, the size is fixed, right? So when we implement queue using an array, so we have to do this circular thing, right? Where again, if I implement, if I show it, so the size of the array is fixed, right? This size is fixed. We can't do anything about that. So when we implement queue now in a situation like this, so our front is over here, our rear is over here. So when we add a value over to here, we need to shift this rear from over here to over here. So that means this is the end of the queue now. This is the end of the queue. This is the front of the queue. Clear? So this is like a circular thing, right? With the time goes on, our front will shift from over here to here, over here to here, over here to here. Our rear will also now from move over here to here, over here to here, like this. That clear? Can we start our array from index 203, not from 0 as usual? It doesn't work like that, right? So array, when we implement array is 0 base, so we call it 0 base. So our indexes start from 0, right? So so we actually there are ways to implement arrays using one base. That means the arrays start, the index start with 1. That's a little bit complicated. So basically, those who don't understand, please ignore this. So what we can do, if you want to have an array that is that where the indexes start from 1, right? So like this, what you need to do is physically it is start from 0. You can't do anything about that. Physically it starts with 0, but you can have another variable, right? So basically, yeah, let's say you declare a variable called index, int index, and this one you can map it to the correct index, right? Whereas, so this is like index, right? This is like index, right? So you can map it to the correct index by decrementing by 1. So basically, when you use, let's say our data, data is our array. So when you use index, right, as the index variable, so you can simply do this, right? So that's kind of the only way you can have array with one base starting with index starting with 1. Physically it starts with 0. Hope it's clear for you. So those who don't understand this, just ignore. I mean, this is something extra, so you need to clearly know this. So, yeah. Any questions with this? I understand this might be a little bit confusing, but that's how it is. Um, so let me know if you have any questions. I'll give you 1 minute for you to do the coding. Then we'll go for DQ. Type it in the chat if you have any questions. So let's go to the next function, which is DQ. With DQ, what we do is, this should be int. So we are taking out the first value, first one. Like we are basically serving the queue, right? Whoever is at the front of the queue, we'll serve him. So this is that. So the meaning is that. So DQ means we take the first person or the first element in the queue. We take it out from the queue, to serve, right? Whoever is in the front of the queue in the gas queue or the petrol queue, he'll get gas or petrol, right? So something like that. So quite similar to pop operation in stack, right? So whereas in pop we take out from the last node, right? So it's we take it we take out the last element, whereas in queue we take out the first element. So can someone tell me what the first thing we need to do when we take a value? So when we insert a value, we first need to check whether the queue is full. Now when we take out a value, what's the first thing we need to do? Anybody?
Whether it is empty.
Yeah, correct. So someone tell me how do we do that? Yeah, I got the right answer in the chat, so I'll just go with that. So we first need to check whether the queue is empty. So we can do that by using simply we can check with size, right? So if size is exactly equal to 0, can print out a message saying queue is empty, right? Right? Yeah. And yes, one more thing we need to now. This is there's a return type integer, so we need to return something. So in this example, let's return the minimum integer value that there can be. In order to do that, you need to include a library called limits. Yeah, there's a library called limits. To have that imported, what you can do is you can return the minimum int min. Sorry, it's int min. Yeah, it's int min. You can return the minimum integer value that there is. So this basically indicate the queue is empty, or that this basically not a valid operation. Once you call this function, if it is not a valid one, you can just you can return this value so that the user can know that operation wasn't successful. Else, now else means now our queue is not empty. There are some elements, so we need to take out the first one. So can someone simply tell me how do we access the front of the queue? So we have this data. So data is the array. So how do we access the front of the queue? Veeravardhana 3775. Tell me how do we access the front of the queue? What should we write here to access the front? Three seven seven five. Veeravardhana. Did you say something? I couldn't hear. I can see that you're trying to say something, but
Can you
yeah, yes, Veeravardhana, tell me.
can you hear me?
Yes. Tell me how do we access the front? What should we write here? Veeravardhana, I can hear you. Tell me.
0.
0 is it'll be correct in only in one instance. So so if you have a queue like this, right, and if your front is over here, then only that will work, right? So if you add 0 over here, so it will work. However, I told you, right, the queues can be the queue is like a queue can be something like this where our front is over here, right? So in that case, it's not correct. So we can simply use this front variable, right? So we don't have to give a numerical value. We can simply use the front variable to access the front of the queue, right? So data front, that means we access in the front of the queue. So now, yeah, let's keep it in a temporary variable. So we have the front of the queue assigned to the temp, and then we need to shift the front, right, by 1. However, we have to do the same thing to front. what we did to rear, we need to do the same thing to front as well. We need to take the modulus, we need to do the modulus separation and by divide by capacity, right? Because the same thing. So once the front goes shift from 1 by 1, once it reaches here, so we need to shift it all the way to the front, all the way to the first element, right? So hope that is clear. And then what else? Yeah, I decrease the size of the queue by 1, and then yeah, one thing we didn't do is return the value. Yeah, clear? Any questions? Any questions? Please type in the chat if you have any questions. Oh, I'm more than happy to answer if you can speak out. Clear? Okay. So let's create one more function. Let's try to print this. Print. Yeah. And some, if I give you like 5 minutes, can you try to do this and raise your hands once you're done? I'll give you maybe let's see who can do this first. So please try to implement the front uh, function, and please raise your hands once you've done that. Take maybe 2 minutes. It's quite simple. So you might be needing a for loop. So you have to loop from all the way from front to the rear, right? So, and then print the value. Take a couple of minutes and try to do this. Haven't done this? Please raise your hands if you have. Yeah, I'll do it by myself. I'm not sure whether you are doing it or not. So that's the disadvantage of having this distance learning. So online learning. So let me do it by myself. So if you have done, please raise your hand. So now there are many ways to do this. I'll do it in a specific way. So let's have a variable called index and let's assign it to front. So our index now is basically front, right? So we know, right, we know the size of the queue, right? So have a variable to indicate the size. So let's basically loop from 0 to size. That means we are basically looping from the first element to the last element, right? So and let's try to print it out. So now data, let's say there needs to be something over here. I'm not going to fill it at the moment. I want you to answer what should we write into the square bracket. So So what basically I'm trying to do is I'm trying to use this index to loop through, and capacity. Yeah. By now you should be able to understand what I'm trying to do, right? So our index start from front, right? I just write it as well. So okay, and then next I'll explain. So what I have done is there are many ways to do that. So you can do this without the index as well. So let's say this is our queue now, right? This is the front. I'll just type F, and this is the rear, right? Yeah, this is clear. So this is the front. So we have the first element over here, second element, third element, fourth element, fifth element, and sixth element, right? This is our queue, right? So what we have done is we have created a variable called index. So right, index, an index started from over here. I'll just type in, okay, just to be easy. So index started from here. It started from front, and with each iteration we basically printed whatever the value over here, right? So with data index we printed the value, right? And we shifted by, then after that we shifted by 1, we shifted index by 1, so it came here, and then again we printed this value and then shifted by 1, this again printed this value, shifted by 1, again printed this value, shifted by 1, right? Again printed this value, shifted by 1, right? So when we shifted by 1, index came here. However, now we need to shift it all the way to the front. So how we did that was by taking modulus out of capacity, right? And then we went over here. That by that this condition is met. You can do it, figure it by yourself. So by when we come here, this condition is met, right? Because now I is, so it started with 0, I is 0, 1, 2, 3, 4, 5, right? So I is, at this moment, I is 5. Our size is, what's the size of this? 1, 2, 3, 4, 5, 6. 6, right? So this is the last iteration. So we go in and we print, and when we shift it to over here, I will be 6 and this loop will be break, right? So that's how it works. Any questions? Let's just try printing it. Let's see whether it works. Yeah, one thing we need to do is we don't need the ender, right? So ender we need to have at the end. Okay. So hope this is clear. Yeah, let's in the main function, let's call this Q array, type QA. Let's try adding a couple of values. Please let me know if you are having any questions. Said yeah, we missed something. We need to provide the capacity. Let's say the capacity of the cube is 4. Let's try 8. Okay, now we have 3 elements, right? And then let's print it out. Clear? So let's try running this. Any questions? Can someone tell me what should be the output? What should we expect to see? Gane Goda. No, I asked you first from you earlier. 35991 Gunatilaka. What should we expect as the output?
578.
Yeah, correct. So see, yeah, 578, right? So here, let's take out something. DQ, right? Operation to take out is DQ, and let's tell me what should we expect to see here. Someone? Fernando, 3585. What should be the output over here in this line?
5, sir.
Yeah. Yeah, before, right, it was 5. So now let's add a couple of more. The 3, 9, one. Okay, now if we run this, can someone tell me what should we expect as the output? Someone? Gunavardhana 3596. So there will be something, this will print 578, and now as we saw, this will print 5, right? We took out the first element, 5. Now, then we added 3 elements, right? So can someone tell me now, when we run this, what should we expect to see? Gunavardhana 3596. If you observe
7, 8,
7, 8.
3, 9, 1.
Okay, will this be printed? 7839 is correct. What about 1? Now, can anyone who figured this out, please raise your hand. Okay, Vitarana, can you tell me what happens with 1?
Q is full.
Sorry?
Q is full.
Yeah, correct. Right. So if you remember, now our Q is of size 4, right? Now when we add this 3 elements, it was 578, and then we dequeued 1. So then after that, the Q is 7, 8, right? So at this point, Q is 7 and 8. Now we enqueued 3, so it should be 7, 8, 3. And here we enqueued 9, so it should be 7, 8, 3, 9. Now our capacity, we have reached our capacity, right? We have 4 elements. Then when we try to add 1 more element, there should be a message saying Q is full. Let's see. Right? Can you see? So 578 is the output of over here. So we dequeued 1. So that's the output over here. And at this point, there should, so it says Q is full, right? And when we print, there's only 4 elements, 7, 8, 3, 9. Is this clear? Is this clear to everyone? I hope so. Okay, so what do we have to do? And so we did NQ, we did DQ, all the codes are there. We did print, and there's one more for you to do it by yourself. So this is the search operation. So search by index, so you can do it by yourself. And yeah, one more thing, please try to work out, try to implement Q with linked list. So I gave this as assignment for stack, right? So you need to implement stack using linked list, and note that you can't use the original linked list code. Like, for I mean, you have to do it from scratch, right? You have to implement Q, stack using linked list from scratch, right? So please note of that. If you use the other methods, I'll probably give you some marks, but some marks will be deducted. Okay, so you need to do it by scratch, right? Implement stack using linked list from scratch, from the beginning. And then yeah, so far whatever we have done, so we use this size variable, right? We use this size variable. Try to do try to implement all these three functions without the size variable. That will be beneficial for you in the end. I'm just giving you a hint. So try to implement this queue without the size variable. I'm not going to give you give this as assignment, but this will somehow will be tested. So try to implement without the size variable. Okay. Yeah, I think we have almost reached the time, but do we have another lecture now? Vandar, Sarang.
No, sir.
Okay, so let me quickly tell you how to implement queue using linked list. I'm not going to, I have the code, but probably we don't have time to do the coding. I'll just explain. Okay, so let me go over to here. Okay. So how to implement queue using linked list is, so this is a linked list, right? This is now, and we have head is and this is tail. Clear? Okay. So with in queue there are two operations, right? So NQ and DQ. Now one way you can do NQ, or basically you can consider this as the front. You can consider this as the front, this as the rear. If you remember, in stack I use this side as the top, right? So similarly you can use this as a front, you can use this as the rear. So insertion happens from the rear, right? So this is the end of the queue. This is the end of the queue. Now when you need to insert another node, what you can do is, let's say this is the temp. So when we insert, we need to create a node with temp, right? So you can simply link these two over here, right? This will be null, and increase the size and move. Then next thing you need to do, shift the tail from over to here, from here to over here. So that's the NQ operation. Clear? Okay. What about DQ? So for DQ, we'll be taking values from over here, right? So we'll be taking this guy out. So in order to do that, you can simply create a temp node, temp variable, and point to this guy and shift the head from here to here, right? So that will be the DQ operation. Clear? Any questions? I do have the codes for this, but we have run out of time. So try to do it by yourself. Then during the next lecture, I'll explain how to do queue using linked list. But this is the concept, right? Try to do it by yourself. Any questions? So one thing one unique thing about this is we don't need the size variable at all. Don't need the size variable at all when you're using the linked list. Okay, DQ, right? DQ is this. So with DQ, what you need to do is first you need to create a pointer. Okay, I'll just explain again. So you need to create a pointer, no, let's say temp, and point it to head, right? Point it to head. So if I just do it quickly, node star temp, right? And should point to head, right? And then shift the head from here to here. Head equal head dot next. Remember, head equal head dot next. So that means we shifted it from here to here. Then you need to return the value, right? So that's something you need to figure out. So now you need to before deleting this, you need to delete this guy, right? So before deleting this, please record store, let's say in k equal temp dot element. Remember how to access the value? Temp dot element. Then delete. Then delete the temp. Sorry for the handwriting. I'm not quite used to this. So delete temp. So that means we have deleted this, right? And then return K. Clear? Lakshan, is it clear?
Yes, sir.
Okay. So try to do it by yourself. I'll explain in the next lecture. So you don't need the size variable at all. Yeah, that's the thing about linked list, using linked list. Hope this is clear for you. If you don't have anything, can wind up the lecture. Just type in the chat if you have any question. I have one more thing. Now, probably your rep has informed you, right? So yes, you won't be coming on 18th to the faculty. So we have extended it to 25th, right? 25th. Yeah. Yeah, 25th. Because couple of reasons. Like one is during the New Year holiday, you can't come here to find the accommodations, right? Soon we'll display the list. Those who are getting the hostels will soon display, and then we can't start on 18th because we are not sure whether we will be allowed to do that, because at the moment the campus is closed. Even though I did the lecture today, the campus officially is closed. We asked the students to go home on Thursday noon, by Thursday noon. So with the current situation in the country, we are not quite sure whether we will be able to open the campus on 18. But somehow, if we are given the choice to open the campus, we'll definitely open the campus and we'll let you in. However, because it's not quite certain, just to be on the safe side, we have shifted it by 1 week, your arrival by 1 week, so that you can come on 25th, so that you'll have enough time to find accommodation as well. Another on top of that, I don't think we'll get the mattresses by 18th. So basically, to answer this question even, so we have 18 rooms available for you, 18 rooms in the ground floor of Hostel C. Out of these 18, maybe 2 or 3 will go to the union students and the sport captains, etc. So probably we'll have around 15 rooms for you, right, for your bed. So 15 means we can accommodate about 60 students, 4 students per room. So that means 60 students. So that's how much you will be getting, right? Out of your, I think your bed is around 250, right? Is it, what was how many students are there in your batch?
275.
Oh, 75. Okay. So out of 275, about 60 will get rooms, and the remaining 215 has to find accommodation from outside. So the most of you will have to find accommodation. If you can't find a place, let us know. Probably we have some connections, like, I mean, we use some outside houses earlier as hostels, like a couple of years back. There are a couple of houses that we used as hostels. Probably we can give you the contacts to find these houses. So let us know if you can't find houses. We'll try to somehow assist you. But try to find the houses early as possible, because it won't be easy to find houses all of a sudden, right? So the 25th is the date, official date, that you can come. Hopefully we'll get the mattresses by that time. I mean, even after the last lecture, I mean, on Wednesday, I went by. I was a member of this TEC committee to buy the mattresses. We went and checked the samples, so we have approved from our side. Hopefully, we'll get it by the time you come here. And yeah, that's it, right? So, any questions? Any other questions? I mean, any questions related to the course or anything else? Sarang, any questions from your side?
No, sir.
Okay. So if you don't have any questions, we can wind up.